Previously, we created a wallet class with a balanced key pair and public key field. We gave each wallet a balance, but we have yet to create the key pair and public key objects for the wallet. To create these transactions, we use a module called Elliptic. Elliptic is a module in Node that contains classes and methods that enable elliptic curve-based cryptography. Elliptic cryptography is an advanced mathematical subject, but essentially it centers around the idea that it is computationally expensive and infeasible to guess the answer to a randomly generated elliptic curve. For us, in terms of getting a grasp of how it's used in a cryptocurrency, know that elliptic is going to be the module that provides the core private and public key generation for our wallet. Alright, let's install elliptic as a dependency by using the command line. So run npm I, that's elliptic, and then -- save. So again, that's npm I, short for install, elliptic, ELLIPTIC, and then -- save to do so as a dependency. With the elliptic module installed, let's create a new file in our project called chainutil.js right at the root of the project, chain-util.js. Soon, we'll be adding a few more methods that relate to the utility side of the cryptocurrency system. Methods that generate keys, create unique hashes, etc. More than a couple classes in the application will want to use these methods, so as a convenience, we're going to include them all within one class called chainutil. So within chainutil.js, let's create a chainutil class, which is short for chain utility. Within chainutil, let's require the elliptic module that we just installed. The module itself contains an inner object called EC, standing for elliptic cryptography, that we can grab right away. So let's create a constant called capital EC, and then set that to the result of requiring the elliptic module, but then setting that to the EC inner object that is a part of the elliptic module. This EC constant that we just declared is a class. To use methods within that class, we'll need to create an instance. The class itself takes one argument, a string, which defines what curve-based cryptography implementation this specific EC instance should use. Now, there are a handful of implementations for the elliptic curve algorithms, but the one Bitcoin uses is one called SECP256K1. So when we make the lowercase ec constant by making the new EC instance from the exported class, we're going to pass in the string SECP256K1. So after you import the EC class, make an EC constant that is new EC SECP256K1. On a side note, in case you're wondering, SEC stands for Standards of Efficient Cryptography. The P stands for prime, and 256 for 256 bits. In the elliptic-based algorithm itself, a key component is a prime number to generate the curve. And in this case, the prime number will be 256 bits or 32 bytes / characters long. K itself stands for Koblitz, which is the name of a notable mathematician in the field of cryptography. And 1 stands for this being the first implementation of the curve algorithm in this standard. All right, with this EC instance, we gain a lot of power in our cryptocurrency. For one, this instance contains a genKeyPair method that creates a key pair object. So let's add a new static genKeyPair method to the chainutil class. We'll call this static genKeyPair. It has no parameters, but what it does is it returns a call to the EC instance that we created and then calling genKeyPair. This generated key pair object itself is also powerful. With this key pair object, we can use methods that get the public and private key created in this key pair. It also has a sign method, which can be used to generate a signature based on given data. So let's use this genKeyPair method in our wallet class, but first we'll want to export the chainutil class as the default module for this file. So have a module.exports equals chainutil at the bottom of the file. Now within our wallet class, let's create a chainutil constant at the top of the file. So in wallet/index.js, we're going to grab the chainutil class we just created, and that is located one directory above at the root under chain-util. With this chainutil module, we can use a static genKeyPair method to create a keyPair object within the constructor of this wallet. So let's call chainUtil.genKeyPair, and this will create the keyPair object for the wallet class. Then this keyPair object itself has a method which returns the public key contained in the pair. So right away, we'll set the public key to this.keyPair, and then a call to the method getPublic. So right away, we're setting the public key to this.keyPair.getPublic, which returns the public key contained in the keyPair object. Additionally, as one last step, we'll also encode this public key into its hexadecimal string form by passing in hex as a value for the encode function as we chain it on the public key. Great. This creates the keyPair and public key for the wallet class. To explore this, let's modify the dev test script that we already have, and the goal will be to look at the two-string representation of wallet and check out what this public key also looks like. All right, let's head to dev-test.js. Let's highlight all the content and delete it. First, we're going to import the wallet class from the wallet directory, which by default grabs the index.js file. We're going to set a lowercase wallet instance to creating a new wallet class, or rather a new instance of the wallet class. And then as the last line, we're going to log what this wallet instance looks like by calling its two-string method within a console log. So overall, make sure you import the wallet class, you create a new instance of the wallet, and then you log the two-string form of that wallet instance. With that, we're ready to go to the command line and then run the script, which is npm run dev-test. And as we do so, what we find is a wallet that appears to the console with a pretty long public key, which is a long hexadecimal value representing what this public key looks like. And then also the default starting balance is 500. Excellent. With this wallet object, we can now create the transaction objects for our cryptocurrency to represent exchanges between this wallet and other ones. We'll also continue to use methods within our EC elliptic cryptography instance, as well as a keyPair object to support a system of creating digital signatures for transactions, as well as verifying those digital signatures. All right, let's move on.